Hello and welcome to another Solana tutorial. Today we're gonna talk about the new Web3.js again. We did talk about this a semi-long time ago. I think it was the tech preview 1 that we had a look at. And that video is pretty much out of date because the new Web3.js changed a lot since then. And today I want to have a look at what has changed and how it looks now. And also, this video is potentially eventually gonna be out of date, but all of my videos are. So, with this one it's likely to happen a bit quicker though. But in any case, maybe Tech Preview 3 is what we get as the final release or something similar. So mainly this is a video for the developers of the Web3.js. Shout out to Steve and Loris, building quite a cool thing, I hope. But yeah, they're good devs, so it's just me not being as good of a dev to see all the genius that has become the new Web3.js or something like that. And true, in the last video, I certainly didn't use it the way it's supposed to be used. I'm gonna attempt to do it a bit better this time. No guarantees though. And also, it's user feedback that you get from me. This is how I would interact with it, with the docs that are available to me. So if you want to have a look at the new Web3.js, try it out yourself, give some feedback. Now we're still in that stage where we can influence how it looks, and then eventually we're all gonna have to use it. Well, we don't have to do anything. You can also just use the Rust or the old Web3.js if you have to. But there are great advantages to the new Web3.js. The main one I see is that a lot fewer dependencies make life just easier. And also, I always struggle with creating version transactions in the regular Web3.js because it's just a mouthful, as some person put it, and I just don't remember it. And with a new Web3.js, this is gonna be simpler. And today I want to figure out how simple it is, how it actually works. So in this quick, I hope this time it's actually a quick one, video, I'll just go through the Web3.js, and if you're interested, come along for the journey. And if not, I have a bunch of other videos that you can watch. Like if you're still struggling with the basics, this is not the video for you. This is just maybe a bit of entertainment for, I don't know, seeing me struggle to work with TypeScript because I have become a Rust dev. Like for real, I prefer Rust by now. But maybe the new Web3.js will get me back to using TypeScript. We will see. And also, you know, different tools for different... I want to make a rhyme here. Don't find a rhyme. Whatever. Different TP for you and me. Different lib for different people. Okay, stop the rhyming, start the video. Okay, so I'm in the Solana Web3.js under releases. There is the TP3, the technology preview number 3, which has been released 2 weeks ago. And a bunch of stuff has changed. We can see the changelog here. But for that to make any sense, we would need to compare it to the tech preview 2, which was released, you know, some time ago. And that also had a bunch of changes compared to the tech preview 1, which was, you know, even further ahead. That was back in November. So basically, the main thing they changed is they changed transaction to transaction message, which better reflects what is actually built. A transaction message, because the transaction contains of the transaction message plus the signatures. Plus. Well, I mean, I would say I just download it and try it out. Try a demo of the new in your browser. Let's do that. That looks like we have some example code as well. Wonderful. But actually, maybe I don't even want to look at that. You know what? I'm gonna save that for later. And I'm gonna once again first just install it myself and see how I would use it. Because I just set myself the challenge, build a version transaction that, I don't know, does the classic system program transfer. I mean, that should be easy enough, right? So I just do this. Let's do that, but just to make sure, I'm gonna make myself the folder node modules in here, just in case I have a node modules in a parent directory, to make sure it's just installed here in this folder and not messes up my other installations of the Web3.js. And then I paste this, and that should install it in here, hopefully. Yes. Wonderful. And we see we have very few dependencies. Yeah, and I'd say we just start with a new file and we start coding. Import from Solana Web3.js. Now we don't need to write add TP3 because we have the TP3 installed. So it should take the TP3 and then we should see what we have in here. Account address. I think that was or used to be the base 56 encoded address or something. They changed that in the TP2. They changed base 58 encoded address to address. So in the previous video, it was still called that. But then I and other people were like, well, at least be consistent. Either you call everything a base 58 encoded something or you just call it that something. Because the other thing was the signature, not a base 58 encoded signature. So it was just a bit confusing everything and not consistent. So now they have it signature and signature bytes. So signature for the base 58 encoded and signature bytes probably for this thing, the bytes of the signature, which makes sense because like the signature is what we're used to always in base 58 encoding. If we talk about a transaction signature, guess what? We talk about that base 58 string. So yeah, we have those things, but really what do we need? What do we want? They're still base 58 encoded something. They're base 58 encoded bytes. Base account, what's that? Lampard's unsafe beyond. That name is still weird, but you know, whatever. That's the base for every account. So that's the fields that every account has. There are other fields in the account, but you know, like data, but that's not in the base. Yeah, account has the base plus the data and the address itself. And there was another field in the base account that we want to remove or have removed, the other metadata fields that are not relevant anymore. So the new Web3.js also doesn't represent them. Okay, what else? Block hash. Oh, we have a block hash class. Message signer, error, Solana, error, all of the individual things here. So a lot of constants. There are transaction stuff, transaction error, and then a lot of functions as well. Yeah, lots of stuff in here. What would we want to do? Send something. Send and confirm transaction factory. Send transaction without confirming factory. Sign and send transaction. I don't want to let the library do all the things. I'm going to do this. This is a factory. Oh, that looks very Umi style. Why is that? Maybe because Loris was working on it. Yeah. Taking his style to the new Web3.js. There are advantages to that, but also it needs some getting used to it, and I'm just not used to it yet. That's why I don't like it. I don't like new stuff, but I do want to be able to use it. So here we are making that video. So what would that need? The RPC, create RPC API, RPC config is what? Again, I'm going to tell you, I'm going to just attempt to build it myself without looking at the docs or the example code. And then we compare it with example code and see how bad I did. And since that is all optional, I'm going to leave it all out. And then what else did you need? Transport, which is a RPC transport. How do I get that? Somewhere I need to put the URL of the RPC. No, where do I put that? String is not assignable to type RPC transport. Well, what is an RPC transport? This is like a game trying to figure out how this stuff should work. Can watch the time, how long it takes me to do these things. Create Solana RPC. There we go. And then we can put a cluster URL. Ah, that's what we're used to. Wonderful. And the config stuff. No config. And then we have an RPC. Wonderful. But that is still weird. What does that return? Send transaction without confirmation function. And the function takes the fully signed transaction and the config and returns a void promise. Internal only, do not export. Great name. Wait, so does that mean that I now call this thing with a fully signed transaction? I mean, again, it's a bit weird to get used to how that stuff works. But yeah, here I would then put the transaction and some more config. So those are we know those things, right? We can define the commitment, pre-flight commitment, skip pre-flight, max retries. Yeah. Let's set a commitment. And now here we only have the 3. In one of the previous videos, I was confused as to why the Web3.js has so many. The other ones are probably just legacy, and those are the 3 ones that actually matter. Let's do a confirmed one. For that, we need an extra transaction. How do we get the transaction? Transaction message is get, set, sign, create transaction message. That sounds like what I want to do. Let's create a transaction message. with a version. Oh, that's nice. I can just say it's legacy or it's version 0. So boom, we already have a version transaction per default. So version 0 is a version transaction in version 0. The difference is how it's serialized, right? So the first byte in this case is 128, indicating that it's a version transaction plus that it's version 0. 129 would then be version 1 and stuff. And then the next 3 bytes are for the header. Whereas with a legacy, the first 3 bytes are for the header. But the first bit in the first byte is 0. Then it's not a version transaction. That's how that works. If you're confused, don't worry about it. And then what do I do with this? Then I get, wait, what does that return? That does, holy shit, this is okay. It returns something that has instructions and a version, but apparently it doesn't have a proper type. What if I would assume that this is my transaction? Okay, cool. And that transaction has instructions and version. So last time I think I added stuff into this, which is not how this is supposed to work. You need to kind of do a something. And I'm not going to look at the example code, but I am going to look at what they had here. Here, they did a pipe. So now they do the pipe with a create transaction message. And then we pipe that message to add transaction message fee pair. Okay, so that thing returns that. And then we would add, so I could also, do it like this and say let that transaction and then the add whatever. No, I don't find that anymore. Set transaction fee pair signer. Set transaction message fee pair. Possibly they have renamed it to set now. Could that be? Which also makes sense because there's just one fee pair. So yeah. And the fee pair is an address. And then the transaction. I mean, this is really difficult to read, let's be honest. Like, if you're trying to guess the types of this is like, whoa. And like new devs will be pretty confused by this probably, I assume, because I'm slightly confused. I still get what it means because it's what we get here, but it's like not a typed type. I mean, yes, it is typed, but it's like, it doesn't have one name. It has like the type of all of it that it's supposed to be. Anyway, so we need the address. I'll call it pair. How do we get an address? Create address with seed. Oh, the new Web3.js should have something like read key pair signer, create. Probably create key pair from bytes is what I want, which takes the bytes. Yeah, okay. But then I would still need to manually read the file and stuff. But okay, I can do that. But then it's still the same as I always do with read the file, parse it, and make a uint8 array from it. And then I can bump that in here, which is the same as I always do. I mean, I heard there is a read from file that makes it easier, but I don't find it directly in here. There might be some helper functions somewhere. But anyway, that's the old way how we always used to do it. And then we create the key pair from it. So then we have a key pair. Oh, wait, no, we need to await this. And then we have a crypto key pair, which has a private and a public key. And the public key hopefully is an address. No, it's a crypto key. Which has an algorithm types usage. Okay, so again, the Web3.js supports a lot more things, so it's not so easy to operate with it anymore. Because you need to specify all of those things, damn. And maybe I'm on the very wrong path here as well. Okay, how do I get an address? Get address from public key. Pair Eddie. Get address from public key. Public key. Why is everything async? Well, it just is. Okay, so we have an address, and then we can set the address. The set transaction message fee pair needs the address, and then that other weird thing that we got up there, which then again gives us the transaction. So we pipe what comes out here in here, and then it comes out here again. And then if we keep doing those things, we would always need to say transaction equals, and then whatever else we do, add instruction or whatever. Do we have something like that? Add signers to instruction? No. Transaction message using block hash. So that we'll definitely need to do. At some point, we need to set a block hash, which takes the block hash, and then again that weird thing. Yeah, that type is just so complicated. But the thing is, it is very accurate in what it accepts and what it doesn't accept. It's actually quite cool because you can't mess it up, but it's really difficult to read it then. That's just feedback, but you know, I'm not judging if it's good or bad, it's just, it is. So, block hash and the transaction again. How do we get a block hash? What even is a block hash? This is so difficult to read. Block hash lifetime constraint. A read only of da 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 da. Well, great. Can you give me like more? I mean, here it does say it nicely. A transaction extends the base transaction or a base transaction message with a transaction message. And here it also says it nicely what it expects. The TT transaction. The TT transaction. So apparently just my Visual Studio already deconstructs what the T transaction already is. And then it gives me a transaction message with block hash lifetime and that T transaction. So we can now guarantee that it's a T transaction and has a block hash. So all of those things are typed, which is really interesting. Because that way it would not allow us to sign the transaction if we didn't set a block hash or a durable nonce strategy, or if we didn't set a fee payer. If you type everything correctly, then you can do stuff like that. And then you would already find those errors at the point of typing and not at the point of running the code. So you would already see that compile time, not at runtime. So anyway, we need a block hash lifetime constraint, which is a block hash and the last valid block height. Oh, we know this. We can get that from the RPC. Hey, RPC, do you have something like... No, you have a send transaction. That's what you have. Because you only have the send transaction API. RPC from transport. Solana RPC API from transport. Maybe I'm getting more. Maybe I'm just typing this wrong. Because now it's a Solana RPC API for test clusters? I mean, yeah, because it is a hold on. Nope, still says for test clusters. Well, okay. Whatever. And now, there we go. Get block height or get latest block hash. That's usually what I do. And I can set the commitment probably. Yeah, I just want the confirmed one. And that will return me a pending RPC request for context and value, and in the value is probably the thing that I want. No, it's not at all what I want. Pending RPC request. Oh, because it's not sent. If I send a pending RPC request, okay, so it splits it's building the request, and then I have the build request, and then I can send it with an abort signal. And that will give me the promise for the read-only with the context and the block hash and latest. Okay, in here, okay. I don't want an abort signal, I just send it, and that gives me the promise so that I can then await, and then my block hash should have the context and the value. Yeah, there we go. That's what I was hoping for. I'm just gonna get myself the value from here. I'm just assuming that this works. I should probably do some checks here, but then I should have the block hash and the latest block height. Should we try if we actually get to that point, right? Let's do that after. And here I would say this. Should we check if we can run it until here? I mean, we probably can't because I can't await on top levels. So let's do the classic async error function that does the following. And then we call it, let's try. What did we call it? tp3.js. Boom, there we go. We get a block hash and a block height. That's working perfectly. We can use the TP3 to work with the RPC. Yeah, nice. And then we can build the transaction. Yeah, and so we always need to, push that in here, get it out again, push that in here. And the cleaner way to write this is as they suggest with the pipe, where we just pipe all of that transaction coming out into the next thing, transaction coming out into the next thing until we are done. And pipe comes from where? There is a pipe in the Web3.js. Okay, now I'm curious what that is. Aha. Oh, this looks like a great thing. Oh yeah, of course, just add everything and yeah. any number of values to pipe through. So with that implementation, it literally just allows us to pipe 10 things, right? That's wow. And if we want to do more, then we need to pipe inside a pipe. But okay, sure. Whatever. I take it. We probably at that point don't want to do more than 9 things anyway. So yeah, we get the transaction out and we pump it in here again. It doesn't look that much different than what I had before, but that is the same thing. And yeah, should we try if we can send that now? Send transaction without confirming. And then we call it with the transaction, but there some types don't match. Haha, there we go, because we are trying to put a transaction in that is not signed. It needs to be a fully signed transaction, but it's only a transaction with a block hash and a fee payer. So what we gotta do is somehow sign that transaction. I'm sure there's something in that library. Sign and send, sign bytes, sign transaction. Or sign transaction message with signers. Let's try both of them. This thing takes key pairs and the transaction T, which is message bytes and signatures. Or sign transaction message with signers. That one takes a transaction message, the TT transaction message, and gives me a promise for a fully signed transaction. And that has a block hash as well. But it needs a compilable transaction with signers. Yeah, let's try to use this one. Sign with signers. The transaction message is actually this. Should I now call this TXM for message? Nah. Too lazy. And I can put in an abort signal, but no, you'll be quick enough with signing that I don't need to abort this. And that will then give me, oh, where do I see that there are so many things? And then it gives me a promise for, because the types are so long, I never see what it gives me. Come on. Gives me a promise for a fully signed transaction. We just saw that. Okay, I just forgot. The TX again is this, which means I could have as well just bumped it into my pipe here. There we go. Now we have a promise for fully signed transaction. So we now need to just await this. Something is wrong. Or is that just my Visual Studio? Oh yeah, there we go. Thank you. Read only fully signed transaction. And then it accepts it. However, do I now get a signature back from this call here? This is so weird because that's a factory. And then calling the factory gives me what? A promise for void. So, okay, nothing, which is not particularly useful. So maybe to start with, let's actually also confirm it. Let's do send and confirm. And there we have 2 different strategies. One's with a durable nonce and one's with a transaction factory. This one is for block hashes and this one is for durable nonces, because we already saw here it needs to be a fully signed transaction plus a transaction with block hash lifetime. So yeah, let's do send and confirm, which probably does the same thing with the RPC and the transaction. Oh wait, hold on. RPC, and then we call that factory with that transaction and our config. Oh no, RPC now needs to be something else. RPC subscriptions. Okay, because now I not only need the RPC, but I also need the WebSocket for commitment checking, right? Because I check if it got confirmed, and that it does with the WebSocket probably. So I need that subscription thing. Oh man, so RPC and then an RPC subscriptions. Create Solana RPC subscriptions takes what? The cluster URL. So I would assume it goes like this with the WebSockets. Let's try. And we comment that out. Something is weird though. My Visual Studio doesn't like it. Probably again some circular dependencies or some weird stuff that it doesn't properly like format that. Like, yeah, now it's the way it is, but it's not usually that slow. Something is still a bit weird here. Maybe it doesn't like the types or whatever. I mean, it is complicated and stuff, you know? Anyway, what does that return? That thing, the factory gives me a send with lifetime function, and the function I can give the transaction and the config, and then it will give me a promise for void again. Okay, So again, that's a bit unsatisfying, must admit. But we just say we await this and then say we are done. And because I always like to print my signatures, I'm gonna print the transaction signature, which shouldn't be too difficult to get that from here. Because this has signatures now, nice. Which is what? A signature map. A map, ordered map with address and signature bytes. Can I access an ordered map with indices like this? I mean, it is ordered, but it might not know what the first one is. Okay, so then I guess with a pair address maybe? Yeah, wait, yeah, maybe. And that will now, hold on. The signature is that, and the signature is signature bytes. And how do I get a signature from signature bytes? Get signature from transaction. Haha, how about that? That gives me the signature. Do I get the implementation as well somewhere? No, I'd like to see the implementation because it probably does pretty much that. I want to see the implementation. I can get a signature from a putative signature. Is that the word for it could be a signature? And then if it's a signature, then it's a valid signature. Could that be? Putative. Generally considered or reputed to be. Yeah, so a possible transaction, possible signature, but might not actually be a signature. Yeah, I don't know how to get from signature bytes to a signature. This can't be too difficult because that's just a buffer. And there it takes a string. Anyway, let's just not, and just get the signature from the transaction because we have such a nice function here anyway that just gives us the signature, and then we have a signature that is actually a signature of type signature that I can neatly print, hopefully. So we print that and then we try to send it, and then once we get the done, we know that it is confirmed. That's the behavior I would expect to have here. Let's see. Do I get a block hash? And then I get a dying script. Okay. What's happening? Did get a block hash, but then assert transaction is fully signed. Apparently you say it's not fully signed. Is that what you say? Decode this error by running. Whoa, what is this? I like the colors. Transaction is missing a signature for address. Context, addresses. So apparently I did not sign. I mean, yeah, sign transaction message with signers. I just put in the transaction, obviously. Something, I'm effing up something here. Hold on, sign transaction with message signers. Expects the message, hold on. Yeah, I don't, but where do I put the signers? I just put the transaction message and then the config just contains the abort signal. Where do I put in the crypto key pair that I actually sign? That is weird. Yeah, and confusing. Because, I mean, I would expect that I can give you like my key pair here. Okay, let's see again. Signers that may be stored in iAccount signer meta. This will ignore transaction sending signers since this function does not send that transaction. Okay, so we somehow need to put that meta in. This is complicated. Message partial signer. Add signers to instruction. Add signers to transaction message. Instruction version signers and transaction message. Aha. All right. Cool. So before we do that, we need to add signers to transaction message. I mean, sure. Here have the signers in the form of an array. You just get my payer and the transaction. Damn, you need something else. Crypto key pair is not a transaction signer. TypeScript. Types. Just playing with types. I mean, I kind of prefer Rust. Just saying, but you know. But the naming is nice enough that I can figure it out. So, transaction message signer. Okay, maybe something like from key, create signer from key pair. There we go. That will give me a key pair signer. Okay, one step at a time. What did we say? Create signer from key pair. Pairs my crypto key pair. Then we have a key pair signer. That now the correct type? Yeah. So a key pair signer seems to be a whatever that thing expected, a transaction signer, which is a transaction modifying signer, transaction partial signer, or a transaction sending signer, which are address and sign transaction. So it has an address and the sign transaction function. I mean, it is built pretty neatly, must admit, but also very confusing if you get started with it. Okay, whatever. So if I add that signer now, then this thing can actually use that signer to sign the transaction. And then hopefully, nope, still not. Still the same. Now I don't know anymore. Maybe the sign transaction message doesn't sign for the fee paying. Okay, let's make it easier for ourselves for a bit. Sign and send. Sign and send transaction with signers takes the transaction and the config. But it doesn't accept that transaction because it's not a compilable transaction with signers and all of that stuff. That makes this confusing to read. Okay, 1.5 hours and I still didn't manage to send a transaction. Not even an empty one. Well, okay, let's make it a non-empty one then. Add an instruction and then hopefully it will think that it needs that signature. So how do we add an instruction? Add signers to instruction, get signers from instruction. Append transaction message instruction. Prepend. Let's append. And it takes again the TTs. If I'm going to use the new Web3.js, I'm always going to call these TTs. TTs! Just because I like it. I like them TTs. Sorry, I got distracted. Instruction and transaction. Okay, the transaction I have, and then the instruction is again a transaction with instruction and number. Okay, hold on. One thing after the other. Append transaction message instruction something and then the transaction. Okay, and that something hopefully we get somehow from a system program transfer or something. I'm also going to find that system. Nope. I want a transaction builder. Oh man, how do I find all that stuff? I'm sure there are helper functions on how to do this. There are interfaces for it. Instructions with accounts, instructions with data, instructions with signers. Well, let's see if I can build that manually. It's not like I'm not used to building stuff manually. So a program address, I can provide that. That's the system program. But how do I get an address from a string? Oh, this is so difficult to get started with. I think I want to cheat and see how to do that. It can't be that it takes me 2 hours to send a transaction. I'm gonna cheat a bit. Look at this demo here. Basically, for now, I just want to find out how I get an address. And the demo doesn't really say that. But it has a write memo that it gets from, that's a function here, okay. Yeah, so that I did correctly with the WebSockets and the HTTPS. That seems to be cool. So that's how it does it. It builds the send and confirm transaction from the send and confirm factory, and then you can just call send and confirm transaction. Yeah, that makes sense. You don't need to make the factory every time. That makes sense. Create a message, set transaction fee payer, set message lifetime with block hash. That it does the same way. Yeah, there we go. It gets the value from this. I also figured that out. And then it appends transaction message instruction, and there it gets a add memo instruction. Where does that come from? From Solana program memo. Okay, so now we have a add Solana program. And add Solana program compute budget, and probably also a add Solana program system or something. Okay, what would happen if I say install me add Solana program? No, that's not a thing, but I can say memo, that is a thing. I can do a memo. Is there a system? Would be my guess for the system program. Looks good. Okay, so system program. I mean, you gotta just know these things. All the wonderful things of the system program. Transfer. Get transfer sol instruction. It calls it transfer sol to not confuse it with transferring tokens. Wonderful. And that gets me an transfer sol instruction. And here I could also now say system program address, which is an address. Aha, so that's how it works. Address, and then I could have just written it in here. That's how it would have worked. Okay, let me check. That's how it would have worked. No, that's the type. Oh, you know what? Never mind. Never mind. And we're gonna maybe do that later. But for now, we want to get our instruction from the get transfer sol. Get transfer sol instruction, which takes Amount, destination, source. Wonderful. Source. What's your type? What's it supposed to be? Transaction signer and address. Okay. So the transaction signer is the signer, and the destination, you know what? I'm gonna say is my payer ID. I'm gonna send to myself. I can do that. And the amount is 1 Lampert. YOLO. Don't send too much, because we literally have nothing for now. But we want to get to the point of having a signed transaction. So if I now add that transaction instruction to that message of that transaction, would it now let me sign it? Or do I still get the it didn't sign? Probably still that. But I like this. No! Transaction simulation failed. And the simulation is null, 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 null. We have no accounts, no inner instructions, no logs. But okay, we get a transaction simulation failed. But that means it now did in fact sign that transaction, right? Because if I leave out that append, if I do the same, then I get the expect signers. BS again. Transaction missing signers. Okay, so apparently having it as the message fee payer is not enough for this signed transaction message with signers to actually sign. So it's weird. Can I find a different strategy to this? I mean, at the partially sign, it says that, right? The partially signed transaction message with signers says that in the docs that it will ignore transaction sending signers since this function does not send the transaction. And apparently that guy is a transaction sending signer. Okay, I still don't fully get this, and I am okay with not fully getting it. You can't understand everything on the first day of working with it. Plus, it might change again anyway. Yeah, okay, but then let's continue with the previous error. The simulation didn't go through. Guess why? Well, because we don't have any funds on there. I mean, I could now do that thing that they do here with the airdrop factory and then call that airdrop and airdrop myself some lamperts. Should we do that? I mean, I guess why not? Such that we once do it. Get an airdrop factory. Import that. So here with the airdrop factory, we create that airdrop, which is actually a function. So now we can call airdrop. Yes, TypeScript is weird, but whatever. With a commitment, lamperts, recipient address. Recipient address is my payer ID. Commitment is, I don't know, who cares, confirmed. Lamperts is 1. Do we have lamperts per sol again? I don't know. Just gonna do this. And it doesn't really like lamperts because number is not a lamperts unsafe beyond. Okay, so I need to tell it that that's lamperts. And that is in Web3.js, right? Yeah. Number's not assignable to big int. Well, then make it a big int. Hey, nice. And that should just do the airdrop. This will probably not work many times, but maybe one time it works. Let's see. Requesting airdrop. Airdrop done. Not sure if it actually worked though, but because it feels so fast. Do I need to send that as well? Hold on. Airdrop factory gives me a promise for... I hate that it doesn't show me that directly. This is so freaking annoying. The function gives me a promise for a signature. No, that should have actually come back. Let's check Solana balance. I do have 1 sol, so actually, yes, the airdrop did work. And then it complained that decode transaction simulation failed. Yeah, probably because it did the simulation when it didn't have the up-to-date state, because for some reason I didn't await this. I didn't await this. I would have to do this. I could print the airdrop signature and then it should work. I mean, now I don't need to do it again, but nope. Requesting airdrop and then probably I have my limit reached. Internal JSON RPC error. Yeah, probably airdrop limit reached. But it doesn't matter because I already have 1 sol. So let's not worry about this and just run it without the airdrop. And we get a signature. But that's just the printing of the signature of the signed one. And now it's done. So that means the signature is also confirmed. Because I was waiting for it with confirm, a confirmed commitment. Let's see here. Yep, we actually did send and we did do a system program transfer and transfer one entire Lampert to ourselves. Amazing. We can use the TP3 to actually work with Solana. Wow. Just took us 2 hours. Easy. But yeah, I mean, almost good enough, right? We did manage to send the transaction. What more do you want? I don't know, building proper instructions ourselves. Like how do I build an instruction myself if I don't rely on, you know, those builders? I mean, I would really like to see the implementation of this just to get an idea of what it looks like. But I mean, that can't be so difficult. I mean, that is open source somewhere. Oh, that's actually good to know though. Sorry for being so bright. The new version of the Web3.js, and there's a shortcomings, yeah. But then it has all those, there is a separate package for accounts. Nice. Errors, RPC, signers, sysvars. Yeah, all the sysvars, I was missing them. Solana transaction objects. So I need all of that stuff. So, but yeah, cool. If you don't need that stuff, you don't want to have to import it, which makes sense. But if you need it, you can import it. And that's cool. I mean, I could make like 10 videos on all of those things. I'm not gonna, but I do still wanna, you know, build a manual transaction. I mean, a manual instruction. I'm assuming I could build an instruction like this. And we're gonna do the same thing as here, just that we wanna manually build it, because I always like to build my stuff manually. So the system program, oh, actually I still didn't figure out how to do that address, assuming I would figure out how to create an address. I mean, that can't be too hard. In the old one, it was new public key and string of the public key address. I hope it's not much more difficult than that, but it seems to be way more difficult because I also don't see any reference anywhere. That's because you didn't look at tests. Okay, let's look at tests. S address. Is it that simple? Is it that simple? Are you fucking kidding me? Could I be like this string S address? Okay. I think I struggled with the exact same thing last time. Okay, cool. But you just gotta know. If you know, you know. Man, I could of course use the static thing, but if I wanted to call my program, then I would need to do it like that. Anyway, so we need the program, we need the accounts, and we need the data. I feel like I did the exact same thing last time, but we're gonna do it again because I completely forgot what I did last time. So accounts is what again? An array of account methods. Apparently it's enough to just provide the address and the role, and that's sufficient. So I don't need that index, probably. I'll just provide the address, which I say is me, my pair Eddie, and no lookup table. Index I ignore, and the role is a writable signer. Hey, that seems to just work. Cool. So that's the first account. And then the second one I also again sent to myself. This one is just writable. Those are the two accounts that I need for a system program transfer. And then the data, what format is that? A uint8 array. So that is, let's give you an array like. And you get, first of all, I want to transfer, and I know by heart that that's the discriminator for transfer because I've been working with Solana a bunch. System program is like my home. And then the amount of Lamperts. I'm going to now transfer 42 Lamperts and then have the rest 0. And that's 8 bytes. So that's 1, 2, 3, 4, 5, 6, 7, 8. And that should be the data for a system program transfer instruction. If you have the impression that I'm a magician for knowing that, then that's because I am. No, I just work a lot in that space. But hey, that should be a valid instruction that I can pump in here and then just have that work, right? Right? Huh? It's a valid transaction and it's done. Here we effing go. System program transfer, send 42 Lamperts. Told you. Easy, easy. We can manually build our instructions ourselves. It is actually a bit confusing. What confused me here, actually, to be more concrete, is that when I add such a account here in this list, it tells me all of those things and it doesn't have a question mark to it. So I'm assuming that I need to put all of them, but it's okay to just have the address and the role and not have it be at the lookup table address or whatever index. Yeah, that's what confused me here. Just to give some feedback on why it took me forever to build this. But yeah, so that's the manual way to do this. But let's be honest, this is definitely easier. You want to do this. You want to import the @Solana program, whatever, and the SBL stuff, Solana SBL token stuff, if you want to work with tokens. Actually, is that compatible? Or is there a token? Yeah, there is a Solana program token, which has, account state, close, token, get revoke instruction, get approve. So something like a transfer checked instruction, which will return a transfer checked instruction of the token program with the source. And it is very, very strictly typed. But yeah, that is essentially what you could then plug in here as well. If I weren't doing that, I can just create a transfer instruction. I don't know, I transfer one token with 0 decimals. The authority is my signer. The destination is myself. The source is, damn, no, that would be token accounts now. Find associated token PDA. Okay, the seeds are those things. Mint owner and token program. Should we do it? Fine. Just so we play around with it a bit, but I don't want to do everything. I'm just gonna SBL token, create a token real quick and say this as an address is my goddamn mint. So I have the mint, the owner. This is gonna be my payer Eddie token program address. It's the token kek. I probably need to await this. And then it still doesn't like it. Address with a bump is not, okay, fine. Not gonna use that bump. ATA. And that's the way it would work, except I now have 9 decimals and I don't have any tokens to send. So create account for this token, the 7WW, that should now also be my ATA, and then SBR token mint. There we go. Now we have enough. Now to transfer 1 tokens, I would have to have 9 decimals here. 1, 2, 3, 1, 2, 3, 1, 2, 3. Then I transfer 1 out of the 2 tokens. Actually, I should transfer it somewhere else. No, let's transfer to myself because I'm lazy as fuck. And just see if that works. That's the instruction. I put it in here. I could sign the transaction. I'm sending it and it got confirmed. You don't see many changes, to be honest, because obviously I sent from here to here. You know what? I will send to somewhere else just to demonstrate this is actually working. Should I send the token to the mint? No, that doesn't make sense. I send it to the system program to never get those tokens back. Just to send them somewhere else. Here you go, system program. Have a freaking, oh no, this didn't work. I'm not even gonna read this. I'm just gonna run this and then I see those nice colors. Invalid account data for instruction. Oh, because that account doesn't exist. Fair point. Get create associated token instruction. Oh shit, then I need to sign with a system program. That won't work. Okay, fine. Send it to a random new address. Generate a goddamn key pair signer. This is also weird that all those things are to be awaited, but yeah, I mean, efficiency, but a bit annoying to write. But therefore you could also run it in parallel. That's actually quite nice. So we create the receiver ATA with that mint, and the receiver address is the owner. The payer, I can pay for it to the fcares, and those I guess it takes automatically, so I don't need to provide them. Oh, because it needs to be a signer. Fine, then I use the signer, which is the same thing except this one can sign. It's both from those payer key pair. Okay, and then the destination here is the receiver ATA, and that should then work, except I now also need to add that instruction before, or actually what I could do is I could do pre-pen transaction message instruction just to confuse you. This will now put that instruction, the create instruction, before that instruction. Just because it's stupid. Of course, you would probably want to append them in the right order, but I can also just prepend them later, just so you've seen that as well. Okay, but now that should hopefully work. Yeah, we get a signature, wonderful. It's even confirmed, wonderful. And we see that this transaction sent me a token to that other random address. Nice. We can use the web TP3 productively. And it just took us 2.5 hours to get that sorted. Yeah, I mean, conclusion, it is nice to have it structured like that, where we have the individual programs with all the things and, you know, the system, the memo and the token. It makes it quite nice to work with. It definitely needs some time to get used to it. There are probably more helper functions for things like these, like reading from a key pair. I just didn't find them yet. You probably don't want to build instructions manually unless you have to, if you don't have an IDL. Yeah, working with IDLs, that may be topic for a future video. But yeah, once you figure it out, it is quite simple. It is actually really not that difficult to work with it. I mean, especially how to get a version transaction. You just literally use this line of code and bam, you have your version transaction. And then you can, you know, work with it. And then you can, you know, sign it. Still some things that are weirding me out, where I don't understand why it's not signing just with a fee payer. I can't sign it like this. I haven't figured out why that is or how I can fix it. Wait, set transaction message fee payer signer. I could say signer here and then provide my signer, and then I don't need all of that stuff. Then I don't need to add that signer anymore, I think. I just need to add it if it's in the instructions, I guess. Actually, I don't think that I need to add it. Let me just try. I don't need that anymore because it's as a signer. Yeah, also works. It will also work without any instructions. I can now send an empty transaction. I just need to provide the fee payer as signer. Yeah, there we go. That's how you send an empty transaction as well. Figured that out in the last minute. There we go. An empty transaction with no instructions. We can totally do that. Wonderful. And I can, of course, also add the compute budget instructions and everything. That's also in the example here with the prepend. So overall, quite nice. I don't have anything where I'm like, oh, this is definitely, this looks weird. This is named strangely. I mean, yes, it has very long names and everything, but I guess I will get used to that. And I yeah, the transaction factory, maybe I should also reiterate that you probably want to create that factory once and be like send and confirm transaction is my send and confirm transaction factory that I await. And then this thing, oh wait, I need to say this is const. And then I can just call this thing because this is now a function. And then I have this send and confirm transaction function. Yes, I know TypeScript is weird, that I can confirm like this. So that's what we're used to. We would just import that. But here I just factor myself that function once with the right RPCs. And you just gotta get used to that. But yeah, also that will just work. It's literally the same code, just a bit different. Yeah, cool. And with that, I want to end it. I think we covered a lot of ground. Like, that's a good intro to the new Web3.js. Actually, I don't actually think that it will change that much more. It might not. If it will, I make another video, but for now, this is what we have. I mean, I would say you can start using it. I mean, definitely better than the old way of creating version transactions in TypeScript, because that was horrible. And might as well get used to it sooner rather than later. I mean, especially if you're starting out, if you're new to Solana development, why not get started with the new Solana Web3.js? Then you don't need to learn all the old stuff. You can just learn the new stuff. The disadvantage of that is most of the docs and most of the answers on the Solana Stack Exchange are about the old Web3.js, but eventually it will become the new one. And if you want to be a hipster and use it before it's cool, start using it now. Okay, that's my speech. And I'm gonna see you in the next video. There are some old ones. I'm not even gonna link the one about the previous Web3.js video that I made because it's kind of irrelevant with this one. And yeah, like and subscribe, and you know, we'll see each other sooner rather than later. Till then, bye bye.